Hello everyone, my name is Huitrand and I am a research associate at University of North Carolina Chapel Hill Institute for the Environment. Today I'm going to show you a tool that I developed to run scripts in the EPA Emission Modeling Platform, or EMP, using a graphical user interface. The demonstrations that I'm showing here is based on the smoke training data package that we've been using for our smoke training class. We provide such class twice a year, one in April and one in October. What I have in front of me is the Linux command line interface, which is a standard way how we run EMP's run scripts. Let me first start transitions into the directories where the main directory setting scripts is located. The directory definitions is the SCI scripts that it provides when you download Emissions Modeling Platform package from EPA. As part of their installation process, you would need to update several environmental variables, including install dir, met root, to match with your system. There are also the scripts where you provide information about modeling scenarios. For example, we have in here is 2022 HE_CB6_22M, which is a case name for the EMP 2022 V2s that we base on to develop this training package. Other important parameters including the grid parameters, grid names, and speciations mechanism to use. Since everything is already set up for this training package, so I'm not going to change anything here, leave it at is. The EMP run scripts are classified into groups that characterize sort type. For example, here we have biogenics, non-point, on-row, point. And let's go into non-point, for example. Here we have run script for multiple source sectors. And let's open the run script for the RWCs or residential wood combustion sector. The past smoke training is that this run script is very difficult to understand by somebody that's not familiar with smoke. Because many variables here, you couldn't find the definition for smoke user guide. They are in fact the variables that used by what we call the EMP helper script that doing some background task to stitch data together, which smoke core program ultimately use to process emissions. So in a way to help smoke user to make it easier to understand the run script and manage the run stream, this is where the new tool that I developed come into place. So I switching here to a new command line interface, and the tool that I want to introduce you to is called SMKRUN. And in my setup, the SMKRUN is the alias that point to the Python scripts that's created under the folder SMKRUN. So we can come back later on how to download and set up its setting the SMKRUN up. But for now, I'm just want to quickly show you what the tools look like and what it can do. So if I type in SMKRUN, it will open Graphical User Interface. So it gives me some initial loadup, and then with that we can start to navigate to the directories that have this EMP run script that I want to execute or manage with this tool. So now I navigate to training and under this folder, and I click into the script. Now remember, this scripts folder, they contain all the run script from the EMP that are classified under the source types. So if I stay at here and I choose. So that directory structure now appear on the left panel like a file browser in a way. And if you can expand those, you can see all of the run script that is located under each subdirectory. Now by default, this browser's interface will filter out for file extensions CSH or TCSH because those are the kind of extensions that the EMP run script normally in. But you can extend the filter to all wildcard, and now you can see additional files appear in these file browsers. Now you can, let me start with the directory definition, the key setting script that we went over earlier. So now the content, there are several tabs in the right hand side of the interface. The source tabs is as if we are viewing the content of the file using the VI editor, for example. So it lists all the content of this directory definition script, and then the tab variables is where it's parsing the environmental setting and then stitching together to come up with the ultimate path or value of each of their variable. For example, you can see here we specify in dir a point to dit home slash cmass as training, and then the subsequent variable is just stitching the value of dir, merge that to IOPI in this case for examples, and it gives the ultimate or the extended path for the locations of IOAPI. Another feature of this variables tab, you also check for the valid of the path. So for those variables that point to the particular file or directory, then it have a check. So we say okay, meaning those paths actually exist in the local machine. Some of the setting is just fully variable, and so it just have this icon or indicator says not a path. And then for some path that is with the red X indicator here, indicate that those path or location is not valid on this local machine. So it is acceptable or expected for the directory definitions settings, the directory definition, I'm sorry, that's related to variable with EMF, because those as variable settings particular for EPA's EMF setup, so it's not relevant for a majority of smoke users who use the EMP run script. There is other tab that shows in this interface, and this will be populated when we actually run the run script, so we can try doing that. But just for example, quickly to see what it does. So now let me navigate back to the run script for an RWC, and again we can go back to the source tab to view the content of the run script as is I opening it up in the VI editors. Certainly I can also jump into this script and do modifications directly on this interface. After editing, I can either temporarily save it in like temporary file or save it to this file permanently. We can go back to this at a later time when we transition to another example. For now, just say that I'm cancels my edit. I don't want to save, I don't want to make any edit on this script yet. Now let me switch back to the variable interface. Um, so what it does here is actually source the directory definition defined in this run script and passing another environmental variable from that directory definition script and then stitching that into each of the setting in this run script. For example, it get that g underscore dat from directory definitions and combine with other remaining path of this surrogate dex, for example, to give us the extending path of this surrogate deck. Now, and again, it also do the path checking. So we see in here majority of the path of our variable that point to a file or a directory is have the green check OK indicators indicate that they are valid or exist in this local machine. For this particular EF table, it says that it not exists in this machine because it's pointing to some file that not exists in this particular machine that I'm working on. But this is okay because this EF table is only relevant when we're processing for on-row emissions and is not needed for processing RWC source sector. So it's totally okay to leave it at is. Now, with the interface, you can do a couple things. First, you can directly visualize or examine the content of each of the files that specifies in this run script. So what to do that, I can right click on the variable or the path that I want to examine. And then I can click on the view edit file and we just open that file with the new pops up window and where I can visualize what is the content in this particular file. So we're looking at here in the descriptions of the Sparse surrogate, which each of the USA is where the country that is applied to, the surrogate code, and with the name of the surrogate and the spatial surrogate file associated with this surrogate code. There's an option that I can jump into the content of this file, do the edits as I need to, and then save it. There are another options that for somebody who doesn't know what a surrogate dex mean. So when you right click, you can click on a define variable. And now this is a window interface, so a couple things. First, it will giving information on what smoke program using this particular environmental variable. So we see in here it's a GridMat, which is a core program for smoke to apply spatial surrogate to come from, for example, county emission level into the model grid cells. It also used by Met4Move in a similar way to allocate emissions from on-road sector into the model grid cells. And the descriptions of this surrogate dex variable. These are briefly extractions of the definitions from smoke user guide. So you can see here there is some reference to figure 4.4 or table 6.37, which you could connect into the smoke user guide. So certainly there is some area that could further improve to add information later on. And we can go over how to do that in the later section. Okay, so again, what available throughout this interface is a couple of things. You can view the content of the files specified by this variable, environmental variables. You can copy the path and open in a different in a separate command line interface using VI editors. You can look up for the definition of those variables, and then certainly you can also change the setting or the values of these environmental variables. You can specify to different path or something else that is up to the user. Yeah, I'm not going to do any modification here yet. Now, Let's say I'm viewing this run script and everything looks okay, so I want to execute or run this run script. So this is where I will navigate to the top right of the interface, and there's a run script option, so I just click on that. Now SMKRUN will ask me for the confirmation that I really want to run this run script, and I hit yes. So now it gives me to the run logs. It gives us the interactive output from the run script, as is we are running it from the command line interface. It's briefly the information of where the status of the run script, what SMK core programs being running. So we can leave it at ease, and now if we look into the input file, this will give us information of what SMK core programs are being run in this particular processing of this particular subsector, and what kind of input file associated with its SMK core program. So we can see in here is for SMK Invent, which is the core program to import emissions from EMP into SMK processor, and along with that is the particular raw emissions file and the list files that essentially contain all of the paths of the raw emissions file. So again, you can right click on each of those and then view contents. So you can see here that particular list file, it just have one file in it, which is specified the raw emissions file from the raw emissions file that being imported in. And this path is particular, essentially similar to the one that we see in here. This also, we also have option to view content of the file. So this input file for RWC is the FF10 non-point format, and you can visualize the content of this emissions file like any other ASCII-based or text-based file. Okay, so as the run script is progressed, you can see there is more program is populated, and associated with each programs again is the input files that being used for each of them. This is SpecMat program where SMK applies the spatiation profile to go from VOC, for example, into the modus species that emission is being processed for. So we see in here some GSPro and GSREF. That's SpecMat is using. We seeing, for example, let me go to GridMat. This is a SMK core program to apply the special allocation. So we see here several surrogate deck, which is a file that we went over earlier, and also the surrogate profile that being written and processed and applied to, for example, go from county level emissions into the model grid cells. Okay, so that is the input file, and it is the output file. So again, they are associated by SMK core program, but now we're looking at the output from each of them. So we see in here is multiple what we call intermediate output files generated by each of the SMK core program, and the temporal file is subsequently used by other SMK core program to ultimately generate SMK output. So we have SMK Invent, we have SpecMat, and intermediate output file generated by SpecMat. Similarly for GridMat, temporals, where it's applied temporal allocations that go from a new emission into the hourly emissions. So you can see multiple output file here. It's for one particular day in the episode we are processing for January of 2022 for example, in this case. And then what we're looking here is an ultimate output from smoke that can be used directly in photochemical model like CMAC, or merged into other emission output for other source sector before using in CMAC, for example. So we're looking here is a several gridded emission 5 that generate for RWC. So we can go over more and more detail later on when we transition to processing for RWC emission sector. And then at this time, it has indications that the run script already finished with S60. S60 is a code indicate that the program was run successfully without any error. So we can go back to the run logs tab, and briefly SMI, there is no error indications coming out or providing from this particular run script. We can go back to the log analysis and analyze current log, which is just skimming through all of the information provided from this run log and just highlight anything that we should pay attention to, or you would catch any error along the way when the run script was processes. So right now we only see some warning and no particular error that could be we should pay more attention to. Okay, so one other feature of SMKRUN is that not only we can visualize the content of the raw emissions file, for example, there are also options that we can visualize or plot emissions from that raw emissions file. So now instead of click on view content, I'm going to plot emissions. And what happened on the background is it's calling another tools that I developed called smoke plot, and it's passed along that raw emission input file as the argument or input to smoke plot. So this is a new interface for smoke plot. It loads that raw emission file in this particular file browsers, and it just coming through the content of the file and then give me the options or it identify the pollutants from that raw emissions file. So here I can choose what pollutants that I want to visualize. There is this smoke plot also pull some online county shapefile for the US to use as a base map where it will map emissions at the county level into the map that can be visualized. So for example, now I click on VOC, I select VOC, now I click on generate plot. Okay, so here is the plot of VOC's emissions coming out from this raw emission input file. Now remember, this input file already extract for this particular 12 list source domain, so it's not cover entire CONUS domain like what the ENP does. But again, for this training purpose, we already extract that for 12 list source domain, so it looks smaller, and this is a sparse extent of that raw emission input file. So what's seen here is the emissions from that raw emission input file and then map into the county map to give us the nice sparse aggregations of emissions by county level. So if we can move the mouse over each counties, and if you look at the top right, there is like interactive values of the locations where my mouse is, where the zip codes or the county codes associated with the location of my mouse, and the values of emissions in VOC in this case. At the top is some statistics including the minimums, emissions values, the mean, the max, and the totals. There are some other interactive options that we can do. We can zoom in particular, zoom windows, and the statistics also update interactively in relative to the viewing windows, and we can go back to our original view. And certainly you can always go back and choose different pollutants, generate plot, and do analysis. You can export this plot into like graphic interface PNGs, or there are also option to export that to other format as well. There are options to view table, which essentially looking at the content of emissions. Now, it's not in the raw F10 non-point emissions format. Instead, it's kind of reorganized the content of emissions into the nice table format where it's break down emissions for each pollutants by columns. And within this table interface, there are several options that we can choose to summarize emissions by state and then export it to CSVs, or we can summarize emissions by counties or by SCCs. Now you also notice that there is an option to summarize by grid cell. However, this option is not applicable for this FF10 known points because the emission file doesn't have specific lat long locations, and without that information, Smugplot unable to map that into a particular model grid cell. So that summarize by grid cells is not applicable for known point emissions from the EMP. And again, for each of the summarize options, you can select export to CSV to save it into external file and use this at the downstream processing. Okay, so we see in that we can visualize raw emission input file, which is in the CSV or text-based format. We can also visualize the smoke output files that are in netcdf format. For example, here again we are transition to the output file tab, and these are the netcdf smoke output files processed for the RWC source sector. So I can right click on any of the output file and choose plot emissions. Again, smoke plot interface appear is load that netcdf file into the file browsers, and then just give me the list of pollutants that's available in that smoke output file. So now you can see here there's a lot more species in comparisons to the raw emission file that we just viewed earlier. The reason for that is because some speciation profile already apply on top of VOC, for example. So instead of just a VOC, we have multiple organic compounds that speciate from VOC, and in this case particular for CB6 chemistry mechanisms. Now let's say I'm click on methane emissions. I want to visualize these emissions and how it look like. So this is at the grid cell level methane emissions that processed by smoke for RWC source sector. Again, you can hold over its model grid cells and see what is the grid cell on the row and column number and the emissions value associated with its grid cells. Zoom in and zoom out just like what we did earlier with the ASCII based raw emission input. But another thing, because these netcdf files also have time dimensions, and what that means is now we can look into each of their time steps in the smoke output file and see how emissions value change over time or associated with its time step. Now we can also click on any grid cells, and that will give us a temporal profile or the time series plot of methane emissions right at the grid cell that we just selected. In this case, grid cell 16.7. similar thing that we can apply for any other grid cells. So there are a lot more options here that can be utilized in the smoke plot tools. We don't go into detail how to use that. I plan to develop some tutorials video at a later time on different way that we can use or configure the plot with the smoke plot program.